we go. Number 17. Number 17. Okay, number 17. I'm going to ask that same question as I asked before.
Yes.
Is this function, is the integrand continuous on the interval?
Yes.
I mean, I don't think there's any place where this function is not defined. All right, so we're good. All right. Therefore, we are going, well, the fact that there's an answer does not actually mean what you think it means. I know it's inconceivable.
Bless you.
All right. So we check the interval. We make sure the integrand is defined on that. So let's go ahead and do our rewrite. The limit as b approaches infinity of x e to the negative 2 from 1 to b. Now, I believe this is tabular method.
I love tabular. My favorite.
I think I want to take the derivative. My derivative column is going to start with an e to the x, and my integration column is going to be e to the negative 2x. Derivative is going to be 1 and then 0. The integrals are going to be negative 1/2 e to the 2x, and then positive 1/4 e to the negative 2x. Do you remember this method?
I do, yeah.
Yeah.
Okay.
Add and then subtract.
Add,
plus, diagonal.
subtract. So the antiderivative of this is going to be negative 1/2 x e to the negative 2x minus 1/4 x. And we're going to evaluate this on the interval from 1 to b. We're looking good? All right. So the limit as b approaches infinity of negative 1/2 b e to the negative 2b minus 1/4 e to the negative 2b minus the quantity negative 1/2 multiplied by 1 multiplied by e to the negative 2 minus 1/4 e to the negative 2. And I want to do some superpluses here, right? All right. So amongst this stuff, it looks like I'm going to get a 3/4 e to the negative 2. Do you agree there? I got a 1/2 and I've got a 1/4 of that same thing. All right. Now let's talk about what goes on here. Well, this one here, it's real easy. B is going to net to infinity. Negative 2b is going to be a really large, thank you, it's going to be a really large negative exponent. That's going to go to 0. What about this one, though?
Same thing.
0 times.
B is going to infinity. E to the negative 2b is going to go to 0. That's infinity times 0. That's indeterminate. So let's just go ahead and let's do a little side work and see what's going on there. I'm going to ask what is the limit as b approaches infinity, but I'm going to write it as negative b over 2e to b. I'm getting rid of that negative exponent and throwing it in the bottom. Because when I put the infinities on here, I get an infinity over infinity. That's indeterminate and it's L'Hopitalable. So we end up getting limit as b goes to infinity of negative 1 over 4e to the 2b. If I did that properly. And that's going where? Where's that going?
Towards 0.
Towards 0. All right. So this is going to 0. This is going to 0. And we end up with 3/4 e to the negative 2.
And that's what I have.
And that's what they have. Check mark. We are so good. I love these problems because they're these new topics, but we get to do all this old stuff too. Revive all those really good memories.
Did you hear the latest statistic joke? You know.